Welcome back to Max with RP. Today we are going to be exploring an important topic, that is triangles, with respect to similarity of triangles and what is the difference between congruence and similarity. So even before that, I want to define what are two polygons which are called, when are they called to be similar. Two polygons are said to be similar if the corresponding angles are equal and sides are proportional. Now look at these two polygons. If you look at the corresponding angles, this is 62, this is 62. Angle C is 88, angle R is 88. A is 100, P is 100, B is 110, Q is 110. So the corresponding angles are all equal. If you look at the sides, DA by SP is 3 by 4.5, which is same as 2 by 3. AB by PQ is also 2 by 3, 24 by 36, which is 2 by 3. BC by QR is also 2 by 3. Then DC by SR is 3.6 by 5.4, which is also 2 by 3. Okay. So each of these sides is 2/3 the side of this. So the angles are equal, sides are proportional, then we say the polygons are similar polygons. Such is the case with triangles also. Two triangles are congruent if the corresponding angles are equal and sides are also equal. That is, if I take one triangle and superimpose it on the other, they should coincide. Then we say they are congruent. When do we say they are similar? If the sides of the triangle are proportional. All the angles are equal, but the sides are proportional. That is, we are either enlarging or reducing. So this is enlargement or reduction. Now look at this. I've got two similar triangles here. As you can see, if this is 79, this is also 79.7. This is also 79.7. Angle B and this angle E, 57.05, 57.05. This is 43.22. This angle is also 43.22. So if you look at the proportionality of sides, okay, that is A by P is 0.5, B by Q is 0.5, C by R, it is also 0.5. Okay. Now I'm going to change the value of D. Now D is 3. Okay. I'm changing the scaling factor. Now what do you observe? Again A by P is 0.33, B by Q is 0.33 and C by R is 0.33. So even if I change the values of D, the ratios are maintained. Now D equal to 4. What do you observe? A by P is 0.25, B by Q is 0.25, C by R is 0.25. So what I am doing here is enlargement. As I enlarge or reduce, if the sides are the same ratio, then we say the triangles are similar. Is it clear? Are you able to follow? Now, we are going to understand a very important property of triangles. Let's go back to this. So we were studying about the proportionality of the sides of the polygon. Now we are going to see about another important property. Now consider a triangle ABC. If a line is drawn parallel to one of the sides to intersect the other two sides at distinct points, say P and Q, then we are going to prove these two sides are of the same ratio. that is AP by PB equal to AQ by QC. This result is called as basic proportionality theorem. Okay, so let me demonstrate again with another triangle. Let me use a different color. So you have a triangle ABC. I'm just explaining the theorem alone. We will see the proof later. Suppose I draw a line which is say parallel to one of the sides. Okay, let me draw a line parallel to AC. Let this be E and F. So now what is given? EF is parallel to AC. Now E and F will intersect the other two sides. It's parallel to AC. It intersects BA and BC at distinct points E and F. According to basic proportionality theorem, this ratio will be the same. What is the ratio? If this is parallel to AC, BE by EA is equal to BF by FC. This result is called as basic proportionality theorem. So now we will see how to prove. Now we are going to explore the basic proportionality theorem, which states that in a triangle ABC, if I draw a line DE parallel to BC, then AD by DB is equal to AE by EC. So you are given a triangle ABC and a line DE which is parallel to BC. Okay, we are going to prove AD by BD is equal to AE by EC. Okay, now to prove this, I am going to consider area of triangle ADE by area of triangle BDE. Now for triangle ADE, if I take AD as the base, then I have to drop a perpendicular from E. So let ES be the perpendicular. So the area will be half into AD into ES divided by, for triangle BDE, what is the area? Half into BD is the base. Since this is an obtuse triangle, this itself will be the height of for this triangle also. So the height will be same ES. So these two gets cancelled, giving you AD by BD. This is AD by BD. Now again I am going to consider this triangle and this triangle. That is area of triangle ADE divided by DEC. For ADE, okay, I can also, for ADE, I can also take this as the base. Then I will draw perpendicular from D. This is the perpendicular. I'll call it T. So the area will be half into AE into for AE, what is the perpendicular? DT. Divided by half into for DEC. Okay, half into EC into, this is an obtuse angle triangle, so the perpendicular again for that will be DT. Now dt gets cancelled, giving you AE by EC. Now this is 1 and this is 2. If you look at 1 and 2, the numerators are same because both of them are area of triangle ADE. But if you look at the denominators, that is the shaded region BDE and DEC, they have the same base DE. So if I want their area, it is half into base into height. They have the same base DE. Height is the same because these two are parallel. So wherever I draw perpendicular lines between these two parallel lines, the length is going to be the same. The distance between two parallel lines is a constant. Therefore, any triangles which lies between parallel lines will have the same height and will have the same, with the same base, will have the same area. They have the same base DE. They lie between parallel lines. So the area of triangle BDE, area of triangle BDE is same as area of triangle BDE is equal to area of triangle DEC, because they have the same base and lying between the same parallel line, lying between same parallels, between same parallel lines or parallels. So if the numerator is also same, denominator is also same for left hand side, the right hand side must also be equal. So AD by BD is equal to AE by EC. So you had a triangle ABC. What was given to us? Triangle ABC. What is DE? DE is a line which is parallel to BC. What are we going to prove? AD by BD equal to AE by AC. To prove that, what are we going to look at? I am going to compare the area of ADE with BDE. It will be half into AD into ES. What is ES? It's a perpendicular drawn from E to this side. So half into AD into ES. For this triangle, half into BD into again ES. For an obtuse angle triangle, the perpendicular will lie outside. That's how you get AD by BD. Now I compare this triangle with this triangle, area of ADE and triangle DEC. You can see that AE, I can take this as the base. If I take this as the base, then this is the perpendicular, DT. So half into AE into DT. Then I'm looking at DEC. It has I can take the base as DE. What will be the height? The height will also half into E. I'm taking the base as EC. Then the height will be DT. Obtuse angle triangle. So DT will be the height for this triangle also. Now if you look at BDE and CED, there are two triangles having the same base DE lying between two parallels. So they are equal in area. So the numerators are equal, the denominators are equal. So the right hand side must also be equal. Hence AD by BD is equal to AE by AC. So I've just introduced you to the notion of similarity. We will look at similarity in great detail in the next video. Until then, goodbye.